Hello guys, in this video we'll learn error handling for our cross-platform applications using Rust. Error handling is one of the most important and critical aspects of your software engineering or application development. Be it any front-end application or back-end application, you must have a solid error handling, and in the case of your front-end application or UI, error handling is pretty critical and should be handled properly for smooth experience of your user or customer on your website. And not handling the errors properly can crash your website and potentially causing downtime and bad customer experience for the specific users. So it's important that we handle those errors and log the journey of our customer in case of any error, so we could easily reproduce and fix those bugs, which we'll understand through logging. How could we achieve that? So in this video, we'll discuss three major techniques for error handling for cross-platform development using Rust. We'll talk about early returns, pass the errors to the child components, or error boundary for properly handling the errors and logging. We'll also try to reproduce what happens when a user encounters some errors and we don't have proper handling for it. How does the website completely crashes? So we'll look at those uh, things first, and then we'll discuss the techniques to solve those problems. So let's begin. First of all, move to the Project Explorer. Make sure you have a nice and clean folder, and inside you have a Dioxus project. Move to main. Now in this video, I'll not be discussing about creating the Dioxus project. If you have been following my series till now, you are well versed with Dioxus CLI. If not, some videos should be popping on right top. Click it, watch it before moving on to this one. So let's start with the techniques. First of all, let's talk about early returns. So as the name suggests, return early or early return. In case of any errors, handle it in such a way that we should return as soon as possible with the minimal damage done and controlling the behavior. So let's see how can we achieve that, or when we need it. Actually, first we try to crash our application with that error, and then we try to fix it with early returns. So let's say we have a count and we use hook to initialize it to hello world. Now this is an undesirable situation because if you see at the name, it says count, so we should expect a number, but turns out it's initialized to hello world. Now we could expect such undesirable situation. This is just one of those examples, but we could expect unlimited such situations in our applications which could occur where we expect something to happen but it doesn't. So we should always handle for the cases when it doesn't happen. So let's say it's initialized to hello world, and what use hook does is when the first time the hook is basically initiated or on the initial render, it will basically clone the value and give you the same value on every render, and the life cycle of this value will be same as the life cycle of your component. So we have use hook hello world, and let's say here we get the value. So what we do is count and parse unwrap. Now I could potentially get some errors while parsing, right? Because this is not a number, but we are not handling for it, and we are expecting it to be a I32. Now let's see what happens. So we have RSX and a P, and here we just set the value, and we have some style with color as white. So we have a basic component and we have a value that's parsed, and we display it. As simple as that, a very basic component. Now let's run this and let's see what happens. So open your terminal and we'll just move to our project and we'll just do dxr. Okay, so as you guys can see, the build is completed, our app is up and running. So we go to the embedded browser on our localhost 8080, and I don't see anything. That's because as soon as it renders, the application crashes, because on parse we are expecting a number, but we are unable to get the number, the error handling is not done properly and the application never gets up. So as you can see, even a small code like this can crash your application. Now let's see how can we fix this with early returns. So these are the cases when we can use early returns. So to use early returns in this case, let's say we are using the early return solution here. And instead of parsing it like this, we'll just add a match here and we'll just parse more safely. And in case of any OK, we'll just set our value, and in case of any error, we'll just return RSX and oops, let's say failed to parse. So basically as simple as this, and rest everything remains as it is. As you guys can see, I haven't touched anything. Just save this and auto reloading done. And as you can see, now instead of crashing, it gently shows us oops, failed to parse. And since we are using a logger here, so we can also parse this error to understand what users are going through in case of any errors, because this is just on the UI, the users will be able to see this, but we can send our error here and set to our dashboards or whatever the logging facility that we are using to check for those errors and fix those. But at least from the customer side, it doesn't crash. As you can see, at least we have something to show. Now here it's just a message, but you could also have a different UI, pop-ups, or whatever you want to show, but more cleaner. So this is how we use early return. Now the next one that we move is pass errors. So let's talk about pass errors. So let's clean this. And first let's try to understand when we need pass errors. So this kind of technique is useful when in case of any errors in any of the child components, you want the error to be handled from your parent component. So let's try to understand such a situation when we have parent-child relation between a component, and in case of any errors from child component, the parent is responsible for handling and showing the UI, so there is a kind of same behavior in case of any error. So let's see. So let's say we have a child component and we call it child1, and in case of any error we have a signal option and static str and element, and here we have a rsx p hello, I am child1, and then we have an input component on input. So move, and we just discard the event, and we can just say error dot set something bad occurred or something bad happened, and we can make this mutable, the error. Now let's say this is our component, and in the parent we have this logic that we have an error state, use signal, and initially we have set this to none, and if let some error, we just return from here displaying some other component which just says an error occurred, please try again. So as simple as this, and then we have our rsx, and here let's say we have our child1 and we pass the error. As simple as this. So basically child renders and on input, let's say we encounter some error while handling this error event, and we want parent to handle that. So let's see with an example and try to understand. So we have the hot reloading going on. Make sure you just save your application and in the embedded browser. Okay, as you guys can see, we have hello, I'm child 1, which is here, and then the input box. And let's say I type something and immediately an error occurred and we get printed. All basically is handled from the parent component. Now how this is useful is, let's say I have another child which is child 2. We just copy this. We have another one that says child 2 and I'm child 2, and let's add a style and color as white. So we have child 2 and we use child 2, pass on the state, and this concept of passing the state we discussed in the second video of the series of advanced concepts. I'll ping it here. If you guys don't know this concept of passing on the state, you guys can check it out. So basically now in case we have two child, in case of error occurring in this or this, it will be handled in the same way. As you can see, our hot reloading is completed, child 1, child 2, and I type in there something went wrong, please try again, and something went wrong. So basically there is a consistency of how the errors are handled, and if you want to achieve that consistency, where in case of error in any of the childs, you want to handle it in same way. You don't want your application to have logging everywhere. You don't have your application to have those caches and all those stuff everywhere. You just want a single point of handling and displaying a different UI, so you have an easier way to troubleshoot. So you can just do this. Your parent do the handling and then pass on the state to your child. In case of error from any of the child, the same UI will be displayed. Consistency maintained. So this is the use case when you can use pass errors, and clean and simple, as you can see the solution. So this is our second way of handling the errors. Now let's talk about third case, which is error boundary, and one of the most commonly used solution across any of the front-end applications that you can see out there in the market. So let's talk about this. So error boundary, as the word suggests, a boundary in which any errors occur, you want to handle it in a specific way. It's as simple as that. So basically you can wrap your components or bunch of components in your error boundary, and in case of any errors, you define the handling that how you want to handle it. It's kind of similar to how this child 1, child 2 situation occurs, but let's try to understand with an example and to envision and better understand. So let's clean it up. Let's move it. Error boundary. So let's start error boundary with an example, and let's say we have a child component, we call it child 1, we don't pass any state, and here let's say just like first example, we have a count and a use hook, and we initialize it to hello world, and we try to parse it so into integer, and we can just do count or parse, and in case parsing fail, just throw. Unlike in the first example where we try to unwrap or handle it with match, here in case not possible, just throw, and if it is, then we just display a p, and here it displays the value, which is our value. As simple as that. Now in case of any error, what we can do is we can just have a rsx, and then we have a error boundary where we can just wrap our component inside a handling. So let's say in case of any error, In case of any error, what we try to do is we have an RSX P with a style as color white, and we just say oops, something went wrong. Now here we could also show a pop-up, a different UI, make a different API call, log it, whatever you want to do. And RSX, here we will just have our component, so child component, as simple as that. So anything inside our RSX first will be wrapped in the error boundary, as you can see. So any error that occurs inside this will be captured by our boundary, and we have our child component. So hot reloading up and we go to our browser, we see oops, something wrong straight away because we are parsing hello world and it gives an error. So let's say instead we change it to 1 2 3 4, and here we do some styling. So style color as white, and let's try to rerun. And there you go, 1 2 3 4. So basically, in case of good behavior, happy flow, or things just work pretty much normal. But in case of an unhappy situation where let's say we get a hello or anything for that matter, and straight away when we go, we just see oops, something went wrong. Now in this error handling, you can literally do anything, and error boundary doesn't have to be on the topmost component. You can literally wrap each component inside its own error boundary as well. Like this component could be wrapped inside its own error boundary, so anything occurring between this will be handled by the error boundary defined in the components. So this is one of the most used technique in the industry nowadays, a production grade thing, and thankfully in Dioxus it's implemented, so you don't have to do anything. You just use this error boundary and rest everything is taken care. So that's it for error boundary. And with that said, that's also end for this video. I hope you guys understood all the techniques that we have for error handling, cross-platform development using Rust. And if you have any comments, any questions, feel free to leave in the comments, or you can join me on my Discord, link in description. I'll catch you guys in another video with another interesting topic. Until then, bye bye.